Welcome back to the very last lesson of Module 5. This is Lesson 4, Compare and Order Real Numbers. Now, you may see I'm dressed a little strange today. That's because we're still in homecoming week, and today is your favorite holiday day, to dress up for your favorite holiday. And my favorite holiday is obviously the best one there is out there, and that is going to be May the 4th. May the 4th is International Star Wars Day, like as in May the 4th be with you. So I have my Jedi costume on and I feel pretty good about it. Our content objective today says students will compare and order numbers in the real number system. Suggested pacing guide says this one should be really quick, which is good because I'm all about a really quick lesson today. The dimensions of Little League baseball field are very specific. For example, the distance from the home plate to the outer fence line is required to be at least 200 feet. The distance from the home plate to the second base is the square root of 7,200 feet, because that's the way normal people write things like that. But remember, a baseball field is, they call it a diamond, but it's actually a square. And since it's a square, all the sides are going to be equal. So if you took the area of the field, found the square root of it, then you're going to know what one side length is. Two measurements found that the Little League baseball field are 200 feet and the square root of 7,200 feet. How do you compare the two real numbers written in different notations? Well, this is all part of what we're going to learn about in today's lesson. You can compare and order real numbers by writing them in the same form. One way to do this is to approximate decimal expansion for each number in order to compare or order the set of numbers. And decimal expansions can be close enough for numbers that are not really, really close. If they're really, really close, then we're going to have to come up with something else. So we're going to move through the sides to see how to compare and order a set of real numbers. And we're looking at 18/5, pi, and the square root of 11. So the first thing they're going to do is they write everything in decimal notation. 18 divided by 5, that was 3.6. Pi, that's about 3.14. And the square root of 11, that came out to be 3.32. For this one, how they refer to it as decimal expansion, or truncating would both work well, because you can see to the 10th place they're all very different. Let's see what they're going to say to do from here. From here they said, well, 3.14 is going to be less than 3.62, which is going to be less than 3.6. Therefore, pi is less than the square root of 11, which is less than 18/5. Easy math. If you were to put them on the number line, they're going to end up looking just like that. Very different locations on them, and compared from least to greatest, they're going to be pi, then the square root of 11, and then 18/5. Now, one thing I would encourage you to keep an eye on is that right there. Your instructions may say least to greatest. Your instructions may say greatest to least. If you don't do what the instructions say, that's going to lead you to getting the question wrong. Example 1 says, which symbol, less than, greater than, or equal to, would complete the statement square root of 8 being compared to 2 2/3 to make the sentence true. Then they want you to take and graph that number, those numbers on a number line. So from there we're going to say, between which two integers does the square root of 8 lie? Well, the square root of 9 is 3, the square root of 4 is 2, so the square root of 8 is going to be between 2 and 3, but it's going to be closer to 3. But then again, 2 2/3, that's pretty close to 3 as well. So let's take a look and see what they say to do. The square root of 8, when you use a calculator to find it, rounded to the nearest tenth, that's going to be 2.8. However, this 2 2/3, that's going to be 2 and 0.6 repeating, the bar notation going over just the 6. But since 2.8 is going to be greater than 2.6, we're going to say that the alligator, yep, it's going to eat the square root of 8 on the left-hand side. Easy math. Of course, you also have to graph these on the number line. So on the number line, square root of 8 is going to be about 2.8. So at 2.8, we're going to take and put a dot. And then 2 2/3, that's about 2.6. So at 2.6, we're going to take and put a dot as well. Whoops, put a dot as well. And from there, if we were to check our answers, we can see that they're the same place I put mine. Only actually, nope, it's not, because I missed something. Mine is 2.6 repeating. And let's zoom out a little bit here. If I did my answers, you can see compared to their answers, the 2 2/3, that would have been 2.66, which would have had it closer to 2.7. So I messed this one up, but I got this one correct. Now it's going to be your turn. Solve this problem and then submit your answer to see how you do. For pi, I'm just going to use 3.14, and for the time's sake of the video, I'm going to go ahead and just use a calculator for you guys. So I'm going to take 3.14, and I'm going to take and hit my squared button right there, and that rounded to the nearest tenth, that is going to give us 9.8. In fact, I didn't even round, I truncated. If I was rounding, that would have been 9.9, but I just truncated to the nearest tenth. Meanwhile, 9 1/4, that's going to be 9.25. So which number is going to be greater? Of course, 9.28 is greater, and that means that the alligator is going to eat pi squared before it eats 9 1/4. So from here, we're going to go back to our problem. We're going to select the alligator going to the left, check our answer, and then we're going to scroll down here, and we're going to take and say, well, the value of 9 1/4 was going to be 9.25, which is going to put us right about here. And the value of pi squared, we said it was about 9.8 or 9.85 actually. So we're going to take that one and we're going to put it right there. And from that, we can take and check what they did. And if we check theirs, theirs is pretty close to mine. They went a little bit further. I'm not sure why they went so far up. I wouldn't have gone that far on that one, but they went a little further to the right on the 9.8 one. All said and done, pretty simple stuff, right? It's just doing basic math and figuring out who the alligator eats. I think you guys can do this one on your own. Go ahead and work it. Remember, you're dealing with negative numbers, and negative numbers kind of flip where things are on the number line, which means it's going to change who the alligator eats. Did you solve the problem? Let's see what they say to do. First thing they're going to do, of course, is convert each of those values into a decimal. They're rounding the decimal to the nearest tenth, and the square root of 6 is going to end up being 2.4, and it says estimate to the nearest tenth, so we're going to use rounding instead of truncating on that one. And of course, that's going to be a negative because the negative sign's out front. And then for here, 3.14 divided by 2, well, that's going to be negative as well. And when you take and divide that, 3.14 divided by 2, that's going to end up giving us 1.57. So, and rounded that one to the nearest tenth, it's going to be 1.6. Check our answers. They didn't round, they truncated. Check it again. Nope. All right, now I'm a little confused. I see what it is. They totally set me up for failure. I read my instructions for that one, and it said round to the nearest tenth. I didn't read the instructions for this one because my little head said, oh, it's going to be the same. But no, they went around to the nearest hundredths on that one, which doesn't make a lot of sense. You should be using the same decimal place on both of your problems. Either way, the alligator is definitely going to eat the bigger number, and the bigger number on this one is going to be the number furthest to the right on the number line. The number furthest to the right on the number line is going to be the number on the right, the negative square root, excuse me, the negative pi divided by 2. Check it, and our answer checks. If we were to graph it, we could take the negative 2.4, and that one's going to land right here, and then negative 1.57. That's 1.5. That'll end up being about here, which if we compare theirs to mine, they're very close this time. And you can see that the negative 1.57, it's further to the right on the number line. Since it's further to the right on the number line, that means that it is going to be the larger of the two numbers. Now it's going to be your turn. Pause the video, solve this problem, make sure you are checking the answer here, and make sure you're graphing it here. You might want to graph it here before you put in your final answer there. Now I'm going to go ahead and say that I could answer the alligator part of this problem without ever doing any math, because I know that square root of 2 is going to be a smaller number than square root of 3, but because we're dealing with negatives, I know that it's actually going to be further to the right on the number line, so that means the alligator is going to eat the negative square root of 2. But let's go ahead and look at this in math. So I'm going to take 2, I'm going to hit the square root button, and that's going to be rounded to the nearest tenth place. Is going to be a negative 1.4. Meanwhile, the square root of 3 radical, oh, I went the wrong way, is going to be rounded to the nearest tenth place, a negative 1.7. Since you can see that let's put these two numbers on the number line. I've got a negative 1.4 rounded to the nearest tenth. It's going to go about right here. I've got negative 1.7, I believe was the other one, right? Yep, it's going to go about right there. The negative 1.4 is further to the right. Since it's further to the right, its value, negative square root of 2, is going to be the bigger number. So I can jump back over here, scroll back up, and the alligator is going to eat the negative square root of 2. The answer checks. Very easy math. It's now time for y'all to put on your Jedi robes and step up your game, because we're going to be comparing a set of 4 numbers from least to greatest. And you see it says the set here, but anytime you see braces right there around numbers, that indicates a set of numbers. So to do that, first thing you're going to have to do is estimate each of these, and we're going to write them as they're saying, so we're going to be more careful this time in our reading. Square root of 30 to the nearest tenth, that's going to be 30, and a radical, which is going to be to the nearest tenth, 5.5. If you round it, truncating it, it'd be 5.4. 5 4/5 is a decimal, is going to be 5 8/10, otherwise known as 5.8. Oops, I don't know why I put 4 there for 5.8. And then 5.36, and it says as a decimal to the nearest hundredths, that's going to end up being just 5.36. Check your answers, and oh, I screwed up. That one's wrong because there was another 6 to the right of it, which means that 6, that's going to round up to be 7. Now I got all my happy pieces here. From there, we can take and put them in order from least to greatest. So my least number, that's going to be the 5.37. My next least numbers, 5.5, and then I have my 5.8, and then I have my 6.0, and my answer is checked. Not hard to do, and my little math boo-boo wouldn't have amounted to anything here, but it might amount to something when you're doing them. So be careful you don't make the same mistake I did. Now, if it makes you feel all warm and fuzzy, you can approximate those on a number line, but I really think that our time's better spent doing other things. So instead, you guys pause the video and work this problem on your own. Go. Alright, let me get busy working here. So I'm going to start off with my negative 7. That's just going to be the same thing as say negative 7.0. I'm going to round mine to the nearest tenth. Negative square root of 60 means I need a calculator for that one, unless I just am a glutton for punishment, and that's going to end up rounding to the nearest tenth of negative 7.7. Next we have negative 7 3/5. Well, negative 7 3/5 is the same thing as a negative 7 6/10, which I can write as a negative 7 6/10 as a decimal. And finally, this one here is a little more challenging. 66 divided by 9. Of course, 9 goes into 66. How many times? 6 times, because 6 times 9 is going to be 54. And, oops, nope, I screwed up, didn't I? It is not 6 times. It is 7 times, which is going to be 63 with 3 left over. So that one would end up being a negative 7 3/9, which is the same thing as, well, hold on, we need to do these to decimals, don't we? So we're going to take and add the next in a decimal and a 0. My decimal is going to go up, the 0 is going to go down. 9 is going to 30 3 times, which is 27 with 3 left over. We can annex in another 0, and that's going to give us a repeating 3 value. So to the nearest tenth, That's going to be a negative 7.3. So now we're going to take and put them in order from least to greatest here. The negative 7 is going to be my least. The 66 over 9 became the negative. Oops, hold on. No. These are all negative numbers. So the negative 7 is going to be my greatest. My next greatest is going to be that one. And then after that, we're going to have the 7.6, which is the 3/5. And that means this one here is going to be my least. Remember, when you're dealing with negative numbers, they're going to work backwards on the number line, so you're going to have to look at those numbers as being backwards. I almost made a mistake. If you want to graph it, you go right ahead. I'm not going to do it. But what if they gave this to us as a word problem where we have a mean weather person, and they said on Wednesday there's an 83 1/3% chance of rain, and then on Thursday they said there's a 9/10 chance of rain. So one they wrote as a percent and one they wrote as a fraction because they're just plain mean. On Friday there's a 6 out of 7 chance of rain. That one they wrote as a ratio. Which day has the greatest chance of rain? So to do that one, you're once again going to have to create everything to a common value. So rounded to the nearest decimal, that one is going to be an 83.3. And I'm going to assume we want it to the nearest, they want the nearest hundredth, so that's going to be 0.33. Instructions say hundredths right there. 9 over 10, that's going to be 90.00. And then 6 out of 7, that one's a little bit harder. So I'm going to jump over here to my side sheet. I'm going to put the first number in the house, which is going to be 6, divided by 7. 7 goes into 6 0 times. 7 goes into 60. That's going to be 8 times, which is going to be 56, with 4 left over. Annex in another 0. 7 goes into 45 times, which is 35, which is going to leave me with 5 left over. Annex in another 0. The 7 goes into that 7 times, which is 49, which is going to have 1 left over, and then 7 is going to go into that 1 time. Of course, I could have stopped right there. Rounding that means to the nearest hundred is going to be, oh wait, no. We're taking, and let me go back and look at my instructions here. They want the decimal version. Oh, so I need to change that to 0.83. I need to change that one to 0.90. I was doing them as a percent, and that one to the decimal is going to be 0.86. Check our answers. All those check. So what day has the greatest chance of rain? Well, that greatest chance of rain, that's going to end up being Thursday at 90% or 0.9. Got to read what this question's asking. I'm clearly not thinking good because I almost fell in a trap again. Our last problem works the same way. Go ahead and solve it, work it on your own, and then I'll work it for you and we'll see if we get the same answer. Alright, so I'm going to work these, and we're pushing 20 minutes on this video, so I'm going to go ahead and just use a calculator on it just to make our life simple and get you all out. 5 divided by 24 means that that one rounded to the nearest hundredths place is going to be 0.21. 4 divided by 9 rounded to the nearest hundredths place is going to be 0.44. And 20% rounded to the nearest hundredths place, that's going to be 0.20. The question is, going back over here, in which class did the greatest fraction of our students favor the cheese pizza? Well, the greatest one would have been the second period, 2 over 9. Plug in our second period, check your answer. We're going to skip the apply problem today. Y'all go ahead and get started on your homework. Do the best you can on it. Let me know if you have any questions tomorrow.